Modified Gaussian integral 8. This is the 8th video in the series of modified Gaussian integral. In my modified Gaussian integral, I mean that integral in the in the form of integral from 0 to infinity to the power minus x square f of x dx in this form. And let's see how do we solve this. We basically use the definition of the ORC function. Basically ORC function is defined as, for ax, integral from ax to infinity of e to the power minus t square by dt. Now if you want the limits to be numbers, you can basically divide t by ax. That gives us integral from 1 to infinity of e to the power minus a square x square y and then ax dy. And the second definition, this one we will use over here because that makes things simpler. Integral from 0 to infinity of e to the power minus x square, integral from 1 to infinity of e to the power minus a square x square y square ax dy dx. Now let's take a by 2 common. There's reason by 2 for the by 2. And also let's interchange the integrals. Integral from 1 to infinity, integral from 0 to infinity e to the power minus x square, take this common, 1 plus a square y square, and there's 2x, and since we have interchanged the integrals order, here also this will be dx dy. The reason I have done by 2 and 2x over here is because if you let u as x square, 2x dx will just be du. And now that's just integral of e to the power u times some constant, and we know how to integrate that. A by 2 integral from 1 to infinity of e to the power minus x square 1 plus a square y square by minus of 1 plus a square y square, and then dy. This goes from 0 to infinity. Fine. Now a by 2 integral from 1 to infinity, this is 0, and minus minus plus, at 0 this one is 1 by 1 plus a square y square dy. Now this is easy to integrate, and I forgot something, like ORC function. This is not really only this integral times 2 by root pi, this times 2 by root pi. I'm sorry, I forgot that. And this times 2 by root pi times 2 by root pi times 2 by root pi times okay, fine, okay, times 2 by root pi. And now this is just a by root pi, and that is just tan inverse ay. And also because there's an a as coefficient of y, we divide by a as well, and this is from 1 to infinity. A cancels out, and we basically get 1 by root pi. Tan inverse infinity is pi by 2 minus tan inverse a times 1, and we know that pi by 2 minus tan inverse a is actually cot inverse a, and cot inverse a can be written as tan inverse 1 by a. And that's how we solve the problem. Tan inverse 1 by a by root pi, that is the solution. And to talk about the flow of the solution, so basically we just use the definition of ORC. We make the limits as numbers, interchange the limits of integral, and also solve it, and we get the answer. So that was it. It was pretty simple. Hope you enjoyed the video. Thanks for watching. Look forward to seeing you in the upcoming videos too.